Like if you're new to this session, my name is Mohammed Imam. I'm the Windows Phone Technical Evangelist for Microsoft Middle East and Africa. And as you can see, this is my Twitter handler on the screen, and my blog. That's my blog. You'll find lots of things on my blog related to Windows Phone news and updates and development stuff. This call is 1, 2, 3, 4, maybe the fourth or the fourth call regarding the MEA DPE internship program. In this call we're going to talk about the files and storage in Windows Phone 8. There are lots and lots of things about files and storage. I'll try to cover as much as I can and show you a few demos on the files and storage and how to understand the files and storage on Windows Phone 8. So for the agenda for today, we're going to talk about the Windows Phone 7.1 isolated storage and the isolated storage settings APIs, the local storage and the isolated storage, Windows Phone runtime, the Windows.storage programming, and we'll talk about the differences and the similarities between files and storage between Windows Phone and Windows 8. We're going also to talk about the special folders that exist in Windows Phone applications, which are the shared folders like the media or shell content and the transfers. We're also going to go through exploring the local folder with some tools that we're going to share, and how to use the removable SD cards in your applications, whether to to read from them and so forth. In this session, we're not covering the local database APIs. This is only about files and storage. The functionality there is the same as in the Windows Phone 7.1. There are like these training sessions if you want to check them. It's there for you guys if you'd like to check them. There's also the SQLite database, which is an open source database that is available for native code developers in Windows Phone 8. It's an amazing if you just download the libraries and what have you, it's an amazing tool for if you'd like to use the SQLite in Windows Phone. So let's get started. Starting with the persistent storage in Windows Phone 8. Let's understand how the local data storage is for Windows Phone. So for any application you're having, there are two separate locations on the phone where files and sub directories can be stored. We've got the installation folder and the local folder. On Windows Phone 7.1, on Windows Phone 7.1, the installation folder used to be called app data, and the local folder used to be called isolated storage. So if you have never worked on Windows Phone 7.1, or you have not worked on files and storage in Windows Phone 7.1, then good for you. I think they're going to be easier for you to because it's going to be new for yourself. So firstly, the installation folder. This is where the contents of your ZAP file is exploded on installation. So it's where your content you've included the projects such as images, XML files, read-only, pre-configured databases, whatever that comes with the application. The application files. That's what is stored in the installation folder. So which means that and for you to know, this is a read-only. Everything there is only read-only. You cannot write to that one. That's the ownership goes to the application itself, which means that if you install an app update to your application, so imagine if you're having an application, then you install an app update, everything in the installation folder will be wiped, and then it will be replaced with the new contents of your ZAP file. So what if you want to keep the data? Then you have to use the local folder, which is the other folder that you have in your Windows Phone application, which is a sandboxed area of persistent storage in the phone, where you can use the file system APIs to store files and folders, or everything there is read and writable as well. So whenever an application creates new writable files, they're created in the local folder. Okay. Any questions? So again, let's wrap it up. For any application, there are two folders: installation folder and the local folder. The installation folder is read-only, access from the app, read-only reference database. You can install databases, anything that comes with the app installation, it's installed in the installation folder. Whenever you put an app update, anything in this folder will be deleted, and it will be replaced with the new files coming with the new update with your application. If you need to store anything or any files or anything you created within the application, like you create a file or whatever or settings, you can store them in the local folder so that when you publish an update for your application, these settings or these files are maintained in your next versions as well. Okay. So any questions so far? Okay. So different methods for addressing storage locations. So this table, you can use it as a quick reference guide on how to name files in the different places. So again, if you've used Windows Phone 7.1, it might be a little bit confusing. Because if you take a look at the so let's take it. So this is for the Windows Phone 7.1. The installation folder used to be called app data, and the local folder used to be called ISO store. So this is an example on how to create a new database file or something. Then or a data context object. So what you can do here is that you put the path of the ISO store when you want to create a file or a data context object in your ISO store local folder. While in the Windows Phone 8, things are different. The app data folder here, the installation folder is the app data. This is the local folder. So that's what the confusion might come from. So if you have never worked on Windows Phone 7, then you can just ignore the first row. If you're just working on Windows Phone 8, then just you need to check the last three, the second and the third and the fourth row. So for the files access, there are three ways to access files in the in Windows Phone 8. Either using the Windows Phone 7.1 isolated storage API, which does not give you access to the installation folder, just the local folder, which you can use the storage file and the storage folder APIs. So if you use this line of code, then that gets you an access to the to a storage file, local storage file. An object to referencing to a local storage file. If you're using the Windows.storage API, which is very, very similar to what you use in Windows 8. I'm not sure if Ibrahim covered the Windows 8 files and storage session or not yet. But if he covered, then you'll find lots of duplicates and duplications between both sessions in the APIs between Windows Phone and Windows 8, because these are the runtime APIs that Windows Phone took from Windows 8. So the installation folder is ms-appx, and the local folder is ms-appdata, and 3 slashes and local and then another slash. So if you want to access a file, so here's a reference to a file, and so the way if you want to access a file in your installation folder or in your local folders, in this example it's in your local folder, you can access that through a URI. You put the full URI. Otherwise, you can do just so that's when you can access it in the URI. You can do the same accessing the file via the storage folder reference. All you have to do is just create a reference to the local folder, and then after you refer to that local folder, you create a storage file that accesses that local folder and refer to that file in your local folder. That's a very, very quick reference. Once you get to know what's happening and how to access the files on Windows Phone, you can use that one as a reference for yourself whenever you're building an application that accesses files, and these are the different ways. So again, there are three. So all these different APIs and naming schemes means that there are three different ways of getting a reference to the exact same file in Windows Phone 8. The top one here that you can see, the Windows Phone 7.1 isolated storage APIs. This is how you use the isolated storage APIs to, for example, here to open a file, and so you get a reference to a storage file, and then you get a reference to the local folder, and then you create a reference to the file in that folder that you created, which is the ISF. So in that folder, you created a reference to the captain's log.store. This is a file, and then the file mode you want to open that file. In the Windows Phone 8, You use different ones, like you just create a storage file, and this storage file you can just give it a URI, a full path, so you don't have to specify the folder because you already specified the folder in your path. Or you can use if you don't want to use the URI, you can use the Windows Phone 8 storage APIs, which first of all you have to refer to the local folder first, and then after you refer to the local folder, you inside that local folder you refer to the storage file, which here in this example is captainslog.store. Any questions so far? Anything unclear? Please let me know. Check the IM window. Any questions? Ah, perfect. Please, guys, if you have any questions, let me know. Okay, perfect. Okay. So let's cover a little bit in more details the storage data, storing data using the Windows Phone 7.1 isolated storage APIs. So these are the key classes you will be working with to work with files and settings in the isolated storage. You have to include the system.io.isolated storage namespace in your C# file, and then you have these three classes, these three objects inside your classes. You can create an object that refers to the class isolated storage file, which represents a file or isolated storage area containing the files and directories. Another one for the file stream, which exposes a file stream to access a file stored in the isolated storage. Or you have a dictionary that has a key and a value, that you can store key value pairs in your isolated storage, like for example, a username and then the value of that username, like username and then the username value, or a password and the value of the password. These are the things that you can leverage in the isolated storage classes. So this is an example. So this is very so this slide shows how simple it is to create a file in isolated storage and to write a string into the file. Okay, so we can get a reference. First of all, you get a reference to the isolated storage file, which is here ISF, and then you create the second thing you do is the isolated storage file. It has a number of useful methods for manipulating files. Like for example, here you can use create file or open file, whatever you want here. So in this example, you use the create file, and then you give a name for that file you'd like to create. And then you create a stream writer so that you write to that file, and then you use the write line, and this is the message that you want to include, and that's it. That's how you write data or write a string to a file that you have. So just let me and we're gonna take a look on a demo, on a live demo, how to do that. Loading the data is pretty similar. Just you kind of reverse the whole thing. What you do similar here is you get a reference. So the sequence is similar. The first thing you do is you make a reference to the isolated storage file. So here's the data. You create an ISF file. So you do that. You make a reference to the isolated storage file. The same thing you do when you load the data, and check if the file exists. If it exists, then you want to open that file. So you created a file stream, and then the file stream, you open the file, give it the file name, and then the file mode is open. And then you create a stream reader. On the other side, you used to create a stream writer, and from the stream reader you put the file stream that you put here, and then you read what's inside that file, and then you close the stream reader, and then you return the result, which is what's been loaded. So let's see a quick demo. Do you have a question before seeing the demo, or let me check the IM? Okay, I'll assume that is okay. Okay, let's see a very quick demo for that one. Okay. So this is a very simple application. As you can see here, this is the text block. Okay, the text block where you put the text that you would like to save in your storage file, and we've got two buttons, write and read. and in the code behind in the right folder, that's exactly what we have shown in the slides. You create a reference to the isolated storage file. Now I'm getting an access to the local folder, and inside the local folder, I'm checking, for example, if I'm writing to it, I'm checking if it has a directory called data folder or not. If not, then I'm creating that directory, and inside that directory, I'm creating a file, which is the and in that file, I'm creating the data folder data file.txt. You can name it whatever you want, and then I'm specifying the let me just make it so that it looks the same as in the slide. So here, first of all, you put the path, and inside the path, you don't have to put the full path, by the way, because you're already specifying the folder with the local up there. Okay, so that's why you don't have to put the full folder for that one. And then you put the file mode is open or create, which means that if the file does not exist, then create it. If it exists, just open it. And then after you open the file, you need to write to the file, right? Then you create the ISO file writer, and then which is a stream writer object, and then in that stream writer you just put what's inside the text box that we're having, whatever inside the text box, and then you write that one. Okay, and then the reader, it's exactly the same thing that we've shown in the slides. Create a reference to the local folder that we have, so isolated storage file local, and then after we get a reference to the folder, we identified what folder we'd like to read from. Then we specify the file path. So we create a file stream, and inside the file stream we create a data folder, and that's the file stream, and then we want to open that file from the local folder that we have reference to, and then we need to read and we want to read the data. So that's why we use the ISO file stream, which is ISO file reader, which reads from which create a stream reader from the ISO file stream that we have created above here, which is the file that we've created. So we read the data in that file, and then after we read that data, we assign the data we read to the text block we're having in the main page. So if we run the application, let me run it. So you can put whatever things you would like to add here. So I'm using my keyboard. By the way, you can use the keyboard in your emulator if you press page down. So like I can tell, like my intern or whatever, and then I press right, and then when I press read, it shows the my intern. And if I leave the application, I can even like turn off the debugging here, the debugger. Goes to captain's no, not that one. So if I can just, file storage, Windows Phone 7, if I press read, it will read the last thing I saved in my database, or not on my file storage, not my database, I'm sorry, in the storage file that I'm having here. Any questions so far? Let me check. Do you want me to repeat anything unclear? Guys, please let me know if you have any questions. Should we go? How is the data saved under what extension? How is the data saved? That's how we save the data, right? We use a streamline. Under what I'm not sure what do you mean under what extension. You can create the file, by the way, whatever you want, like .txt file. You can create the ABC file, whatever you want. You can do whatever you want. So you don't have to. I meant, what is the extension of the isolated storage file? I already specified that in the example here. So let me open the example again. I just added a txt file, but I can replace that by anything. By the way, I can put it like .abc, whatever it is. It's a file that is readable, and I add a text to it. So you can specify any format. You can add the text. I'm not sure where this question is here. Okay. So let's get back to okay, application settings. I really love this application settings thing. because most of the applications will, I mean, like would want to use the application settings. Um, so just think of any app, an application that stores any values. That and if you think of a game, and inside your game there are settings like the preferences of your application, whether you're choosing a language, a difficulty, a username for yourself, or some fonts, for example, some colors that you like to, some themes, whatever you want. You want to load these settings whenever you open the application, right? So the application settings you can store in it the username, the text color, whatever objects you do. So it's kind of a dictionary where you add the values or the objects you want to store, so that whenever you open the application, you load these into your application and maintain the same experience that you left your application at. So the Windows Phone SDK, it offers this isolated storage settings API as a convenience to developers. It allows them to save, allows saving of simple settings as a key and a value, like a dictionary. And but however, that usage of this class is not recommended to communicate between program settings between the foreground application and the background agent. And we will go through that into more detail when we talk about the background agent. So just keep that as a for foreground application only. So never use an application setting when if you're planning to use that through a background agent. So saving data in settings is pretty simple. You set values just in any other key value dictionary. So you use the isolated storage settings class, and then inside that class you use the object application settings, and then you set then you specify the name, and you put you assign that name to the value of that key. So we have here a key which is the name, and a value of that key which is the message. So we assign the value of that key to that name. So for example, like a name, and the message would be for example Mohammed. So the name of this application setting, or the name whenever you want to open the application, you want the application to show your name to it, right? So so that's how you can save it. Like isolated storage setting to the application settings name, and then equals the string here, and then you can save this application settings. Remember, you have to save. If you haven't saved, whatever you've done will be deleted once you leave the application. How you load? It's very, very simple. All you have to do is just check application setting.contains, and then you check if it contains that key. If it contains that key, then you return a string of the value of that key, and then that's it. That's exactly it. So let's do a very quick demo in using the settings storage in a Windows Phone. Let me check. Okay. Do you have any questions before we go through that? Questions? Yes, no? Need help with saving object to isolated storage file. We will talk about that actually in the it depends. I mean, like for object we can use the data contract serializer. I can share with you the code for that one. There are lots of things that you can use for storing objects in different files and in your application. We'll talk about that in very soon in the upcoming slides. So for the main application, this is a very I just created the UI. So there's a text box where it contains input data. There's 3 buttons: save data, display data, and remove data. And we have a text block here called user data. And then in the code behind, I just have the 3 buttons here, the implementation of the clicks of the 3 buttons. So in order to do that, all you have to do is you can use the isolated you can use the isolated storage settings, and of course you need to use the system.io. Guys, can you see it from the screen? Would you like to zoom in a little bit? Check. Okay, good. So now I'm creating an object. I'll call it settings. And in my settings, I'm creating isolated storage setting.application settings. That's for when I'm trying to save. So once I create that, I check if my settings contains, and then you put the string key here. Okay, so in my key here I can use like whatever I want. So for example, like user data, whatever you would like to use. And then if it does not contain, then I need to create the this one. So settings.add, and then you add the key that you have. It's a string, so user data, and then the value of it can be like the value in the text box that I have. So this is if I have it. Else, which means that this setting is already there, so it's not the first time I save to that settings. Then I get the value of that settings. Okay, the value of that settings, and I assign the text input to it. Okay, so that's how I save to it. So instead of how to check if I saved it, let's see the display. Whenever I press the display, I want to text display dot text. This is just, because I don't want to change the user data. I'll just tell you right away where I did that. And then the text display dot text plus equal. I didn't want to create two text blocks, so I'm just appending to what I'm having here. So I'm just getting the settings. Oops. Oops. Again. Oh, interesting. So I need to create an object. Actually, I don't need to. Could have created that as a new one, but it's okay. I can just use isolated storage. Isolated storage settings dot application settings, because that's where it is stored. Dot contains, and then check the user data, the one that I created. And if it contains that one, then I want to add to the text display the text and append to it the value of the isolated storage setting, the application dot the value would be a user data. Oops, string, so user data as string. So that should do the trick. So if you just run the application here in my emulator. So let me choose anything to type, like for example, October, whatever, or my name. So if I press save and press display, I should find the my name to it. If I go back, okay, sorry. So the application is called Phone App 24. Phone App 24, and I press display, and I get my name again. Okay, so this is how it is saved for us. Honestly, it shouldn't show it. This is pretty, because I did not save actually the settings. I just realized that. So if I press display again, wow, this is pretty weird. Shouldn't save it. I should go here first and press settings dot save. That's a little bit weird. Wow. I think I need to clean the solution. Sometimes it happens. So you build here, build, clean solution, and then you get one more run. So there's nothing to display. So whenever like input data and then display, it should show that one here. How to remove the data from how to remove the data? You just go to the button that remove, and you just check if it's there. So if isolated storage settings dot application settings dot contains, and then you put the user data, and if it contains that, then you just say like isolated storage dot application settings again dot remove, and then you remove the whatever you want to remove, that one. If it found, just remove it. That's how you say it. So if you run again, display, it's there, remove, display, there's nothing there. Okay. Questions? Do I get any questions here in this call? clear? There are lots of silence in this call today. Yeah. So is it clear, Bassam? And you know. Okay, that's because everything is clear. Thanks, Johnny. That's very diplomatic from you. Okay, that's very good, actually. Okay. I love the fact that everyone finds things very easy and clear. So let's get back to the. Okay, that's a. Just press F5, not Shift F5. Okay. So using phone runtime. So now it's time to take a look at the doing the same thing using the Windows Phone Runtime APIs. For the Windows.storage classes, so there are key classes in the Windows.storage namespaces that you'll be working with to work with files in the local folder, like the so the Windows.storage implementation in the Windows Phone. Again, as we've mentioned earlier, because this is a Windows Phone Runtime API, it's a subset of that one exists on Windows 8, which means that some, but not all, of what we have in the Windows.storage classes is a copy paste of what you can find on Windows 8. So, for example, like the storage folder or the storage file, it's the same way you implement the storage folder or the storage file on Windows 8. However, like there's some stuff in Windows 8, like the application data.local settings. It's only available on Windows Phone. On Windows 8. It's not supported on Windows Phone. However, a simple workaround to create a local settings file, you can create either a custom file or use the isolated storage settings. So these are the ones. So the storage folder, which represents the storage area for containing files and directories, and the storage file, which represents a file that provides message for manipulating them, opening the file, or creating or doing whatever you want with your file. So that's exactly the same thing that you can find and do on Windows 8. So now you're learning two things at the same time with the same code. So you start by using the Windows.storage namespace. Private async, we use the async and the wait again because we don't want to block with big files and big data you want to store. We don't want to block the UI, and I think we've mentioned that in the async and the wait and the synchronous programming, where you move the workload from the main UI thread to a thread pool where the compiler manages that and put that in the thread pool, and once things are done or the task is finished, it returns the value to the main UI thread. So that's when using async and await. So first step when using the Windows storage APIs is to get a storage folder. Exactly the same thing when we use the Windows Phone 7.1 APIs, the isolated storage. So first of all, you get a reference to the local folder. So storage folder equals application data current.local folder, and then you create the file in the local folder. Sorry for that. You create a file in the local folder. So here it is. So local folder.create file async, and then you name whatever the file you'd like to name, and then you specify the type. What happens when you try to create that file? Which means if for example, like open if exists is an option that you can use, which means that you try to open the file, and so this opens the file if it exists. If it does not exist, it creates it from the beginning. So that's the option of create collision option that you have. Then you implement a stream writer, so you can create a stream. We call it write stream, whatever you want to call it, and then it's an asynchronous. You call it asynchronously so that you save the UI of the main thread and make the application more responsive. And then you create the open stream for writing asynchronous, and then the stream writer. So that's for the file, and then a stream writer to write to the file that you've created, and then you write whatever the data you'd like to write to. I think it's exactly the same thing. If you already got it in the isolated storage, it's the same thing here, only with a little bit of await and asynchronous methods, async and await words that we've used, so that we make things more responsive and better for us. And this code will work fine with Windows 8 as well. So loading the data, the reverse operation to read the string out of the file. Sequence is very similar, although we note that we use the get file async instead. So again, you create you get a reference to the file in the local folder. So here's the reference to the local folder first, and then a reference to the file in the local folder dot get file async, and this is the name of the file that we trying to reference to. And then we open it and read the contents. How to open it? We first of all create a stream. That's a stream to the file. So read stream storage file dot open stream for read asynchronous. So it's kind of the stream so that you can read the file, and then this is the stream reader where you can read the content of the file. So read to the end, and then load the results of what you read in the data, which the data is the string that we've created here, and then you return that value. So any questions so far? I think it's exactly the same if you already got the first one. So with the isolated storage, it's the same one, but it's just, you know, with the asynchronous and with the same logic. You get a reference to the folder, then the file, then you create a stream, and then and you specify what's the type of the stream, whether you'd like to do it for, and then you create a stream reader so that you read, or a stream writer so that you write to that file. Any questions so far? Or should I take it as it's an easy one? So Johnny thinks everything is fine. Okay, so no question, then we should continue. Thanks, guys. What about accessing files using the MS app data local or MS AppX? Again, as we've mentioned earlier, in the table, in the guide, in the reference table that I've shown earlier in the slides, the AppX is the file, the things that you find in the application, the installation folder, to make it more clear, and the app data is our local folder. Okay, so app data, and then, you know, colon 3 slashes local and a slash. That's the URI, or the path for the data. So there's no file exist method in WinRT, so we have to try. Okay. So what we want to do is, so as an alternative to using the current folder, the local folder, the ones that we've created in the past couple of slides, you can use the storage get file from application URI, and then you put the URI instead. And the reason why we're putting that between a try and catch, because there is no file exists in the WinRT APIs, so we have to try to open it and catch any exception if there's any problem with getting the file or trying to open that file. So that's why we're putting that between a try and catch. So this is only the way. You just, you know, a storage file. You don't need to create a folder, a reference to the folder, because you, again, as we mentioned, you already refer to that folder in your UI, in the URI, in the full URI. And then if you find it, then it's you can open it. Else you don't. So this is another way of accessing the files. And for creating, and then if the file does not exist, which is what you can catch, so you try to get the file. What if the file does not exist? It will throw an exception, so it will be catch in the catch here, and then you assign the file exists to false, and if the file exists is false, so that means that you'd like to create in the local folder another file which is called myfile.store. So that's how you check, and then create correlation option fail if it exists, if the file exists, which shouldn't be the case actually, because you already went there because the file does not exist. So any questions? Is it clear? I think it's pretty straightforward. Questions, guys? Good, bad, repetition? I love that. I love when I hear the word easy. Okay. So what about Windows Phone 8 and Windows 8 compatibility? Again, the Windows.Storage API implemented in Windows Phone 8 is a subset of that one on the Windows 8. Most routine file and folder access operations are exactly the same, but the roaming data folder, roaming settings API is not supported on Windows Phone, nor is the temporary data store. So like as you can see here, these are so Windows Phone 8 is, so all the data storage uses the local folder equivalent to that one on the 7.1. So only local folder is supported. There are other folders that are not supported on Windows Phone, like the roaming folder, temporary folder, local settings, and the roaming settings as well. These are just for Windows 8. One other difference between Windows Phone and Windows 8 that we can call out is on Windows 8 you can create a bitmap image. Like in the first example, as you can see, you can create a bitmap image object for an image that you have included as a content in your project by using the MS-AppX. So that's how you can use that on Windows 8. On Windows Phone 8, you cannot use the URI syntax in this way. Then you'll have to use the relative path. So this is one difference that you need to know when you're trying to access the AppX folder. So let's see a very quick demo for using the Windows.storage. We're not gonna go. Okay, let me just show you a very quick demo for that one. Captain's log. So that's the captain's log. If you can check here in the main page, let me check. Open the main page. You will find nothing. Just a plus and it will be loaded. So this is the log entries, and then you just add a log, and then whatever you add will be saved to the database. In the app.xaml .c#, we're going to go through that in more details in our next session about the application lifecycle in Windows Phone 8. But again, there are four main methods that we need to know about here, which is the application activated, closing, deactivated, and launching. So launching it, which means that the app.xaml file, you add the code that you'd like to run whenever before the app starts. So if you add any code in the application launching method, then that means that you need to run this code whenever your application is launching from the start. If the application is closing, so if you're exiting your application, then you can add here some code that you'd like to run in your application. For example, like saving data. So normally you save data when you close, and you load the data when you open the application. And the activation is when you're coming back from a safe state. For example, if you get a phone call and then during your game or something, then you need to save some data during this deactivation. So when you're going back, you need to you end the phone call and you're turning back to your application, so that the application activated method is called, and whatever code inside it is run is run in the application. So here's the application and the application launching. Again, we're running the load. Again, we're loading the files from the local folder, and in the application closing, we are we're not saving the application closing. That's weird. Wait a second. So we're saving in okay, because I'm not loading actually, but you can load, by the way. You can load or you can save when the application is closing. That's the way you can do it. But now we're just launching. Whenever we're launching, we're activating the application. We're loading what's inside in the view. So all you need to do here is this is the file storage class you're having here. So there is the save .isolated storage file. Oh, do you have a question? Question about images. I want to store a list of objects in which I have an image, but I want to save it to isolated storage. I have an unhandled exception serialization, so how to save safely an image in isolated storage. Let's go through that when we go to the serialization part. Okay. So again, this is exactly what we've done. This is how to save to local folder. You get a reference to the local folder, again, and then after the reference to the local folder, you get you create the file in the local folder, and if it already exists, you just open it, and then you create a stream so that you open a stream for writing, and then after you open that stream, you create a stream writer so that you write inside the file what you have in your log data string. And for the loading, exactly what we've done, the exact same way that we've shown in the slide. You get the local folder, try to open that file. If the file does not exist, then you create if the file does not exist, then you make it empty. If you're loading from if the file doesn't exist and you're trying to load anything, then you're returning an empty string. If it exists, then you open that file, and then open a stream reader and you read what's inside that file. So it's exactly the same thing we've shown. Let me just run it. So that's we can just continue. So that's one I tried. So I can just type like my second entry, and then I can save it. And here's what if you want to go like a step-by-step debugging. I don't have much time, but I just want to show you. Then you can here's like the log data, the time, whatever you want here. These are all of the things that are available in the log data. Now you're writing that data, and then it should be done. Continue. And then when you go back, let me just stop the debugger, and you open the application back, which here it's captain's log, should be up there. Oops. Oh. Then you find the data that you created. So this is how you can do that. So it's exactly the same thing, by the way, just different programming method or whatever you'd like to use, whether you're using the Windows.storage or using the old ones when developing your application. So my recommendation is, if you're planning to move from Windows 8 to port your app to Windows, or planning to build an app for Windows Phone 8 and Windows 8, then use the Windows.storage APIs. If not, then you can just use the other one, the Windows Phone 7.1 isolated storage. We have a question: does isolated storage local folder persist when an app is updated, say via store? Yes, that's what we mentioned earlier in the call. The local folder, whatever is in the local folder, will maintain when an app is updated, but whatever in the installation folder in the AppX will be deleted with an update, and will be replaced by the new data from your application. So if you're planning to keep data if we're planning, so the settings or the files you download, the scores, whatever you want, you go for a game, for example, you should keep that in the local folder. Otherwise, you put the other things in the AppX, which is only read only, and you might not want to use again in an updated version of your application. Okay. Christian, is that okay, or you need is it clear? Okay. Let's return back to these slides. So we've got special folders in Windows Phone. So all read, writable file, I/O operations in a Windows Phone application take place in the local folder, or in a subfolder you can create below there. So you can create a nested folders, by the way. You can create a folder within that folder within that folder. This area is sandboxed and private to your application. It's not possible to have a common storage area between a different application that a different application can read and write to the same file. There are new APIs in the Windows Phone 8 that allows one application to create a custom file and to send it to another application. For example, you can create a file that you can read in another app. So if you have a Windows Phone application device, and you have, for example, a mail, and then you get a PDF file, or in your WhatsApp application you have an image. When you click that image, well, you open that inside the application. But if you have a PDF file coming to your mail and you open that PDF, it will open in another application. We're not covering that in this app, but I'm just in this session. But I'm just wanted to highlight that one as well. So within the local folder, you can create files and folder just the same as persistent storage to a drive in a desktop Windows. That's the way you can do it. So reserved folders. So in addition to that general storage, the local folder is used for special use scenarios. We've got the shared media folder that you can save album art, images that may be displayed by the shell on the lock screen, in the phone's universal volume control if the app uses the background audio APIs, for example. There's also the shared cell content folder where you can store images to be used on tiles. You might have pulled these images, for example, from a server and created them on the fly using a writable bitmap object. So your background agent or the foreground application can use these APIs to change the tile images. We're going through these tiles in one of the upcoming sessions into more details. And there's also the shared transfers, is where the file that you fetch or file that you send or using the background file transfer service is stored. So that's also is not covered, but you need to know about these three reserved folders in your Windows Phone application. About data serializations and deserialization, just a brief explanation on data serialization and deserialization. What is serialization? Serialization, it is the process of converting an object or a graph of objects into a linear sequence of bytes, so that you can store it or transmit it to another location. Okay, so this is serialization. So what is serialization? It's a process that you convert an object or a series of objects into a linear sequence. Because what we've seen so far, we've just writing strings, to a file. What about if we want to write objects to a file? You can do that with what we've shown so far. You need to use data serialization. And deserialization is exactly the opposite, the process of taking that stored information and recreating the objects from it. So it's kind of, you're breaking down the object into a format that can be stored or transmitted to another location. So data persistence and the app lifecycle. So the application is either not running, it's either launching, it's either running, it's either deactivated or closing. So these are the application kind of life cycle. So again, like as I mentioned before, when the application is launching or being reactivated, you need to load the data, right? So if the data is object, so you need to deserialize that data. So deserialize is you can call it loading, and serializing you can call it saving. So okay, if an app is being dormant or tombstoned, we're going to talk about that in the application lifecycle, session. But this is when you want to save your data to the isolated storage, or the app is being terminated or closing, then you need to save the data. So again, just need to double check to reiterate that. So serialization is the process of translating data structures or object state into a format that can be stored. For example, in a file or a memory buffer or whatever you want, so that you can use that later through a deserialization of the app of that object. So why do we serialize? So a serializer object writes the data of a collection in a memory object into XML or JSON or some other format that can be stored in a file, so that when the app starts, it needs to deserialize that object. There are different types of serializers available. There are XML serializer, data contract JSON. There are lots of things that are available for the open source. You can just use that in your applications if you want. So again, we serialize so that we need to write the properties of a collection of objects into a file so that it can be stored in a persistent storage. And deserialization, we need to kind of recreate that collection of objects and recreate that into our application. So serialization using data contract serializer. So this is exactly the answer to lots of questions I got through the IAM today. So this slide shows a general purpose. This is a general purpose utility method that you can use to serialize any object, a single object or a collection of objects, or a collection of objects such as an observable collection, for example, into a file. So the code is shown at the foot here. It's like simply you need to so this is what you need to use, right? You use, for example, a list of my data objects, can be images, whatever you want here, like I don't know, a dictionary file, whatever the data objects here, and then you call the my data serializer object, which takes the data type you need to save, and then that list can have my data object dot save objects async, and then you put the my objects, the list of my objects here, and then you save that and in the my serialized object.xml file. Honestly, I mean, like, if you need to understand this, I'll definitely go through it, but you can find lots of classes about like this data contract serializer class. It's available. I can share with you the code for it. All you have to do is just add that class into your application and just use that kind of that line of code, actually. So what does it do? Oh, I'm sorry. What does it do? You know, the save object async, it takes the data type that you're sending, and then the target file name. That's exactly what the save object async that we used in the below example. And then then it creates a file, and that file is in the local folder, and then create that file creates a file with the target name, and then if it exists, it replaces the existing file, and then you create a stream which is of an open stream for writing asynchronous, and then instead of stream writer, which we use for writing the strings in the past examples, we create a data contract serializer, which can be of a type of the type that you've passed. Okay, so in this example, it will be my data objects. And then you write this object into an outstream, and then a source, and then you specify the source data that you used, and then you await to this flush async. You just free the stream again after you're done with the outstream. You free it, and then you close it after you're done. So this is when you do with the serialization. Deserialization is exactly the opposite. You call the restore object async instead. So restore object async, you create you create a file which is inside the local folder. Create the file name. So here's how you call it first. You just give it like I want to load the file that I called my serialized object.xml, and inside that file I load so I create a file here, a reference to the file that I created, and then I create an in stream so that I or a stream variable so that I can open a stream for reading, and then I deserialize the objects using the data contract serializer. And then after I'm done, I read the objects, and then add this add the result into an object of the data type that I passed, and then I close the stream reader, and then I return that data that I'm done. I know it might look a little bit different, but actually it's exactly the same thing. But the only new thing we did here, and instead of doing that with strings, we just did that with a generic data type that we're using. So let me even show you that in a demo. So let me try and open a demo. So do you have any questions? I know it can be a little bit different, that one, but it's very important if you're trying to do that with objects. Yeah, that should be the one. So here's a demo or an example of what we have. Here's the data services, my data serializer class with the type the data type. Here's how we can save. Please share the code. I will share the code. No problem with that. So here's the save object asynchronous that you have, and then this is exactly the same code we had in the slide. You pass the data type, storage file, you create a file that is referring to the local folder that you've created, and then if this file exists, you just replace that file, create a stream that is opening stream for writing the file, and then you create. And instead of doing the stream writer as we've done in the previous examples, we're just creating a data contract serializer, which is a class that serializes or deserializes in an instance of a type into an XML stream. So that's exactly what it does. And then I pass the type that I would like to serialize or make my serializer of that type, and then I write an object in the out stream that I created, and that's and then I write the object into source data, and then once I'm done, I flush the stream, and then I close that stream. And when the restoring object or reading or deserializing the object, I do the exact opposite. In the beginning, I make a reference to that file. If that file, and after I refer to that file name, I open the stream for reading the file, deserializing the object, and after I deserialize the object, I'm giving it the data type that I passed in my code. I just read that object and save it in and typecast it with the data type I passed, and then I add that to the data and close the stream and then return that object. Okay, I have a question. Hello everyone, hope you are all well. This is Kevin from the DRC. Please bear with me as I have connectivity issues. Okay, I'm not sure what's that. So that's the class we're having. You can just add that class. You can get a copy of that class. You can just add it to your project. And then all what you have to do is in the in the app.xaml, the C#. So this is what we're doing. We're creating a collection of objects. That's a very good example. Here's a collection of objects, dictionary of string and a string. Okay, so here's the first, second, and third. So here's the first item, whatever data. This is just dummy data, and then you call the my data serializer, and then you save that dictionary and save it in a file called my serialized dictionary.xml, and then you clear that dictionary that you've created, and then you can now deserialize that into and move it back to your object of type dictionary, or to the collection of objects. That's what you can do when the app is launched. So let me try to run it. I think I need it to hold on. Phone app. Actually, I need to kind of do something different. Oh, I didn't even add something to load the data. It's okay. Let's just debug it. So let me start, build, clear, clean solution, run it from the beginning. So here the application is launching. Created the object of dictionary. Here's count 2, 3. Await. Yeah, actually I added that in the. Hold on a second. Command window. And the output should appear here. So now once I deserialize, you can find the count to be 3 again. So let me restart the debug again. So here's just so that you guys know that I've already built that. Oh, okay. Run. So here's I'm creating an object, adding the first item. I have a count to that object of type dictionary. I'm adding second. I'm adding the third. Now I'm serializing these objects, which means I'm saving that to my serialized dictionary.xml. Saved. I'm clearing dictionary, so the count will go to 0, which is done. Now I'm loading that back to my dictionary after it's saved in the my serialized dictionary. And look at that, the count is 3 again. And if you just go to the dictionary and break it down, you'll find the same 3 objects that I created of the dictionary. Is it clear, guys? Or and yeah, object count is 3. Do you have any questions? Oh. So we have a clear message from Bassem. So I think this data serializer or data contract serializer answers a lot of and solves a lot of issues that you guys might have when storing objects to your application. So any questions? You want me to repeat anything not clear? Okay, I mean, like, it's very whatever object you can use, Ismailia. I mean, I haven't tried that with images, but images is an object. Try using that with images. The data contract serializer, use that with images, and let me know how it, because you can create a data structure that can take a string, like a name, and then an image. Because end of the day, I'm saving that into an XML format, and definitely you can save that image to that format. So it should work fine. Where are you going to share this? We have a shared folder. I'll pin the I'll put the folder right after I'm done in the Facebook group we're having. So it's MEA Windows Phone Developers Lounge. You should find things here after the session. So let's return back to the slides. Okay. For the tools, we've got some tools. They're very, very good tools actually for checking the isolated storage we're having. In the isolated storage Explorer, there are some tools that are coming with the SDK, which is the isolated storage Explorer, command line tool that you can use to list, copy, or replace files and directories in isolated storage. You can use that on your emulator or your device. It applies on all targets of Windows Phone OS 0.0, 7.0, or 7.x and 8.0. You can find that file in that path, and that's the syntax, an example of the syntax you can use for it. However, there are other tools that this is a command line tool, so it's going to look something like that. If you'd like to check what's in the settings, what's in the files, and what have you, it might not be a very good or a very user-friendly kind of an isolated storage explorer. So there are some available. So let me share with you the other ones that are available and very easy to use. Here it is, the Windows Phone or the wp-tools.coldplex.com or the isostore-spy.coldplex.com. These are very good. So I already installed on my machine the WP Power Tools. Let me run it. Interesting. Where it is? Okay, Windows Phone Power Tools. So here's the UI for it. It's a very good tool. So because I'm running on this emulator, not the device. So I'm just selecting the emulator, the 512 megabytes. And sorry, and then I'm just connecting, and then I can just go to the isolated storage. These are all the applications I stored. So this is the my serialized dictionary that I stored the things to it. So I can just open. You can even open that, guys. By the way, in try. You can open that in. Let me check. Let me get. Okay, hold on. Let me open application settings, Captain Lock Store. You can get a copy, as far as I remember. I did that before. Browse for folder. Okay, okay. So I get a copy for that one on my desktop, which is here. Now I can open it in the XML, and this is actually the serialized data contract serializer. This is the output that we've got. It's an XML file. As you can see here, it's you can find the key, the first, and the value of it, and everything. Let me use an easier way we can do that. So, for example, I remember we used the data. Should find it here. Data folder. You remember we created the folder in the first example called data folder, and under it doesn't want to open. Yep, here it is. Data file.txt. I can just double click and I add the word my intern. It's in the file, so you can add, you can do whatever things you'd like. That you can even delete the files from your emulator and from your app data. So this is a very nice tool with a really good graphical user interface that most of you guys might want to use it to debug or check your application, how things might look like. Any questions regarding that tool? Should we turn back? I know we're a little bit over time, but questions? Should we get back? Okay. So accessing the SD cards. So this is the one new feature in Windows Phone 8.0. It's the ability for an application to read files from a storage card. This feature is targeted at enabling side loading of large app data files such as maps, large data sets. You can even install files on from the store on your SD card. So Windows Phone 8 devices may support the use of micro SD cards. So not all Windows Phone 8 devices has that support. So for example, the Nokia Lumia 920 does not support external SD cards. However, the 820 does. So depending on your device, so be careful when you're developing an application that uses external storage, because it might not, your application might not work on all devices. However, you should not be afraid of having wrong users downloading the app, because in your application, whenever you're developing that application that is using the removable storage, you must declare the capability in the app manifest file. Once you declare it, that means that users on the store, they will unless they have a device that supports removable storage, only users with devices that can support removable storage will be able to download your application. Others will not even they won't be able to download your application. So this is a very good thing from your application in the SDK. And how you can do it, you can just go. Let me just choose any. So that's any application. If you go to the properties in the app manifest, go to the capabilities. You can just select in this example, it's removable storage. Or yeah, you just check that checkbox, and then you're good to go. And then that means the application will only appear to applications with this capability in the store. Now, do we have a question? Yes, there. I'm sharing a screen. Yeah, B10. So just so this is how the external storage is would appear for users. You the Unfortunately, you cannot write files to your external storage. You can only the only access to external storage is read only, and you can only access file types which your app has registered file association. So your application has to register in the file association. For example, it will need to open a file of type .foo or .txt files. These are the only things you need to add. Um, You'll find that in the app manifest XML. You need to open that in a different format to add this file type which your application should support. These are the APIs for the external storage. I haven't prepared a demo for the external storage scenario. You can find but these are the APIs: external storage device, external storage external storage device asynchronous, which returns a collection of SD cards if you have more than one SD card. So currently, I think this collection will contain no more than one SD, so it should return just one. External storage folder, external storage file, the same name convention, just with the word external at the beginning, and then external storage device get file async or get folder async, which obtains a file or a folder directly from the external storage and device object. So for some best practices, you might want to check which is the quota management. Windows Phone applications do not have a limit on the quota for storage in the disk. It's up to you as an application developer to do the right thing and be, a good, citizen to on your user's device. So do not try to use all the phone memory for the application. So you make so your application. So you can, if you have a 10 gigs of space, your application can use them all. So please do not do that otherwise it's necessary. So application must be careful using that space. Use only if necessary. Be transparent about storage usage. Whenever Windows Phone when a Windows Phone has only 10% of storage space remaining, the user will receive a notification of this status. They can then perform actions such as deleting pictures, music, and applications to create the necessary storage space. So I don't think it's something that users might like. If your application has large data storage needs, consider whether you can store some of the data in a cloud service. If you're planning to large data storage, I think a cloud service might be a better alternative. Otherwise, if the data storage requirement for application will grow based on user choices, you should expose the size that is taken up by each choice they have made in a settings page, for example, and give the user an option to delete that data. So that it's just how smart you can use this thing for synchronization and stuff like that. So again, and then if the size of the structured data, such as database, can increase over time, you should find a way to communicate this to the user. The user needs to know it. It should be a good thing if you can tell the user that this is how your application is using. The application is using lots of data or not, and so forth. Serialization threads. If your status information is a complex object, you can easily save the object by serializing it, and I think we've shown that. Note that serialization may slow down the saving and loading of data, so you should use the threading in the situation. That's why we've been using the async and await in that one. So I think that's it so far, and I think we're really good on time. We're not that bad like past things. So do you have any questions? Anything might not be clear to you guys? Do you want me to repeat anything unclear? Is it hard? Is it easy? Okay, it's useful, which is good. Okay, perfect. Guys, please, if you have any questions, let me know. I hope this session really covered lots of things about the storage and how you use your storage and best way to use that, and the serializer and what you can use. And I really hope to see your applications using this, and be more than happy if you share that with me, so that I see like how your apps are looking after the session. So any questions? Okay. Thank you, Wael. Thank you, Christian. Thank you, Chevo. Thank you everyone for making the call, and looking forward to seeing you next week. I think it's going to be on application lifecycle. I'll need to check the agenda. I might change the schedule for November. There's a session that I might not be able to deliver in that time because I'll be traveling. I'll be on a plane actually, so might not I wouldn't be able to deliver a session from the plane. We don't have that technology yet, but thank you for making it to the call. I will let you know if there are any changes in the timing of any of the sessions, but that's going to be like next month in November. I'll let you know in advance.